take a look at this problem. This also is a problem that is in using the trig identities. However, I want to go a slightly different way about it. We have to find all 6 trig functions. Basically, we have done this earlier in the semester, but let's repeat it again because this is a really important concept you definitely have to know. We're using the right triangle relationships of our trig function. Now this one says the tangent is 2/3 and the cosine of x is greater than 0. First of all, you have to figure out, okay, in which quadrant would this angle be located? If the tangent is positive and the cosine is positive, then we are in quadrant 1. Remember, all students take calculus. So students in second quadrant, let me repeat it, the sine is positive and the cosecant. In quadrant 3, the tangent and cotangent are positive. And in quadrant 4, the cosine and the secant are positive. So the only quadrant where all trig functions are positive is in quadrant 1. So now I draw a little sketch of my relationship. Here's my angle x, theta, however you want to call it. Now the tangent, by definition, is opposite over adjacent. Now we have to label our sides. The opposite side to the angle is this one, that would be 2. Let me write it here. Opposite over adjacent. The adjacent side is 3. Now we need to find all 6 trigonometric functions. We already have one, that's the tangent. Now based on the tangent, we can find the cotangent without any problem because the cotangent is the reciprocal, and in this case that would be 3/2. We have to do a little work in order to find the cosine and the sine by finding the hypotenuse using the Pythagorean theorem. 3 squared plus 2 squared equals the hypotenuse squared. 9 plus 4 is 13. That's the hypotenuse squared. If we take the square root, we have the hypotenuse is the square root of 13. Okay, now we have everything, so let's find the sine of x. The sine by definition is the opposite over the hypotenuse, so this is the opposite side, this is the adjacent side, and of course the hypotenuse is always opposite the right angle. 2 divided by the square root of 13. We need to rationalize, so multiply by the square root of 13 to get rid of the radical in the denominator. That leaves you with 2 square root of 13 all over 13. Once we have the sine, the cosecant is the reciprocal, so the square root of 13 over 2. Now the problem, cosine of x would be adjacent over hypotenuse, 3 square root of 13. We multiply, we rationalize the denominator, and get 3 square root of 13 over 13, and the secant is the reciprocal of the cosine, which in this case is here the square root of 13 over 3. So here we are. We have all 6 trig functions, basically a review of previous sections we have looked at. The book may use the fundamental identities. We don't really have to do that. My triangle works just perfect for this. Here we go. That's it. We're done.